It weighed 390 grams. It was the size of a paperback novel, roughly the thickness of a deck of cards. The screen was small, monochrome, and in bright light almost impossible to read. By every objective measure, it was inferior to its competitors at the time of launch. The Sega Game Gear had a color screen. The Atari Lynx was faster and larger. Both were more powerful by every technical specification. The Game Boy outsold them both by a margin that was not even close. It sold 118 million units over its production life, and it was built in a city in western Japan that had been making things carefully for over 1,000 years. Kyoto. Inside a Nintendo production facility that most people who ever held a Game Boy never thought to wonder about. This is what happened inside that building. Nintendo was not a technology company by origin. It was founded in 1889, 90 years before the Game Boy, to make playing cards. Hanafuda cards, the traditional Japanese flower card game, hand-printed on mulberry bark paper. By the time Gunpei Yokoi joined the company in 1965, Nintendo had moved into toys and was beginning to experiment with electronics. Yokoi was a maintenance engineer. He was not supposed to be an inventor. He was walking through the Shinkansen production floor on a quiet day in December 1979 when he noticed a businessman on the train platform playing with a liquid crystal display calculator, pressing the buttons absently to pass the time. He came back to the office and wrote a memo. The memo described a handheld electronic game device using a low-power LCD screen, not because LCD was the best display technology available, but because it was the most battery efficient. Yokoi had a philosophy he called withered technology, mature, well-understood technology deployed in new ways rather than cutting-edge components chasing performance at the cost of battery life and price. The Game Boy was the fullest expression of that philosophy. It used a Sharp LR35902 processor, a custom chip combining elements of the Intel 8080 and the Zilog Z80, running at 4.19 megahertz. It had 8 kilobytes of working RAM. Its screen ran at 160 by 144 pixels, 4 shades of green. These were not impressive numbers in 1989. They were the numbers that allowed the Game Boy to run for 15 to 30 hours on 4Ah batteries. No competitor came close to that endurance. The Game Boy was manufactured at Nintendo's Uji Ogura Plant, a production facility in Uji, a city just south of Kyoto known for its tea cultivation and its ancient temples. The factory floor was clean, organized, and lit by fluorescent overhead panels that cast an even white light over rows of surface mount assembly machines and manual workstations. The contrast with Atari's converted California warehouse could not have been sharper. This was a Japanese precision manufacturing environment of the late 1980s, orderly, methodical, with quality processes embedded at every stage rather than checked at the end. The Game Boy's main board was assembled using surface mount technology, the Sharp LR35902 processor, the RAM chips, the display controller, the sound amplifier, the crystal oscillator. Each component was placed by automated pick-and-place machines onto a board slightly larger than a matchbox. The populated boards moved through a reflow oven, then to automated optical inspection, then to a manual verification station where technicians in white gloves examined flag joints under magnification. The housing was 2-piece injection molded ABS plastic in Nintendo's signature light gray. The molds produced the front and back halves of the body, and each piece was inspected for surface defects before it was passed to the assembly line. The buttons, the D-pad, the A and B buttons, the start and select buttons were molded from a slightly softer grade of plastic and tested for actuation force and tactile response. The A and B buttons had a specific travel distance of 0.6 millimeters, not approximately 0.6 millimeters, 0.6 millimeters. The rubber dome beneath each button had to collapse and recover at a consistent force across the full production run, because the feel of those buttons, the specific click under a thumb, was something players would spend thousands of hours with. Nintendo's engineers understood this. They had spent years with the Famicom and the NES understanding that the interface between the player's hand and the machine was not a secondary concern. It was the primary one. The LCD screen was manufactured by Sharp and arrived at the Uji Ogura plant in protective packaging. It was bonded to the polarizer and the glass substrate in a clean room environment. with a controlled level of particulate in the air, because a single dust particle trapped between the LCD and the polarizer would appear as a permanent dark spot on the display. A permanent dark spot on the display meant a failed unit. Workers handling the screens wore full clean room garments, gown, gloves, face mask, booties over their shoes. They moved carefully. They handled one screen at a time. The cartridge connector, a 32-pin edge connector at the bottom of the unit, was tested to 10,000 insertion cycles before the design was released to production. 10,000 cartridge insertions and removals without degradation of contact quality. The battery compartment, which held 4 AA cells in a sealed door at the back of the unit, was tested for contact resistance after a simulated drop, because a drop that loosened the battery connection would reset the game in progress, and a reset during play was a failure mode Nintendo was determined to eliminate. Each completed Game Boy unit underwent a full functional test. A test cartridge was loaded. The display was checked for dead pixels and uniformity. The buttons were each pressed to verify actuation. The speaker was tested for frequency response. The link cable port was verified. The battery door was opened and closed. Then the unit was played, not by a machine, by a person. A human tester ran a test sequence on each unit, moving through specific in-game scenarios in a test version of the firmware that exercised every hardware function in a defined order. The test took several minutes per unit. It was not efficient. Nintendo kept it, because a test that required a human to actually play the device caught things that automated tests missed, subtle screen artifacts, audio anomalies, button irregularities that were within specification but felt wrong in use. Felt wrong in use was a failure condition at Nintendo. By 1990, the Uji Ogura Plant was producing Game Boy units at a rate that struggled to keep pace with demand. The launch allocation for North America had sold out within weeks. Lines formed outside toy stores before opening time. Parents called stores to reserve units. The holiday seasons of 1989 and 1990 saw supply exhausted at retail within days of each shipment's arrival. The competitors with color screens and faster processors sat on shelves. The Game Boy with its green display and its 15-hour battery sold out every time it arrived. Yokoi's philosophy had been correct. Players didn't want the most powerful device. They wanted a device they could keep playing. In 1996, Nintendo released the Game Boy Pocket, a smaller, lighter revision. In 1998, the Game Boy Color. In 2001, the Game Boy Advance, with a 32-bit processor and a landscape format screen. Each revision came from the same Uji Ogura facility, each one building on the manufacturing processes refined over the original's production run. The Game Boy Advance SPI, released in 2003, finally added the backlit screen that players had wanted since 1989. Production of the original Game Boy had ended years before. The Uji Ogura plant still operates as a Nintendo manufacturing and distribution facility. It does not look like a place that made one of the most important objects in the history of consumer electronics. It looks like a factory, which is exactly what it was. Gunpei Yokoi left Nintendo in 1996 following the commercial failure of the Virtual Boy, a product that had abandoned his own philosophy and chased performance at the cost of everything else. He died in a road accident in 1997. He never saw the Game Boy Advance or the Switch, the direct descendants of the idea he sketched in a memo after watching a businessman press calculator buttons on a train platform. The original Game Boy is still the most resilient portable console ever manufactured, not because of its specifications, because of the decisions made on the production floor in Uji, by people who understood that the device they were building would spend 15 hours at a time in someone's hands, and that every detail of its construction had to be worthy of that.